Right, calculations. These are absolutely guaranteed to come up, but there aren't that many of them. First one, relative formula mass, which is called MR. So relative formula mass of CO2. They'll give you, in brackets, numbers next to the atom. So C is the number 12, O is the number 16. And to work out relative formula mass, all you have to do is use the formula to see how many atoms you've got. So I've got one carbon. Carbon has a mass of 12. I've got O2, two oxygens. Oxygen has a mass of 16. So I've got one 12 because there's one carbon, but two 16s because there's two oxygens. Then I just add all this together and I get an answer of 44. I want you to have a go yourself. Do these 4 questions, all right? Relative formula mass, I've given you the individual mass numbers. See if you can work those out. Okay, so here are the answers. The first one, I've got one carbon with a mass of 12 and 4 hydrogens. Add that all up and I get 16. The next one, 2 nitrogens, each have a mass of 14. Add it and I get 28. The next one, I've got 2 hydrogens, each with a mass of 1. Then I've got a sulfur with 32. And then I've got 4 oxygens, each of them are 16. Add it all up and I get 98. Now if you don't want to write this out 4 times, you could have 16 times 4 in a bracket, but I've just written it all out. The next one's maybe a little bit harder because I've got a bracket, all right? So there's only one calcium. Okay, but oxygen's in the bracket and there's a small 2 outside the bracket. That means I've got 2 oxygens. So I have the number 16 twice for the 2 oxygens. Hydrogen's also in the bracket and there's a number 2 outside the bracket. So again, I've got 2 hydrogens, so I've got the number 1 twice. Okay, add that all up and I've got 74. The last one I'll do with you, it is a bit harder. So I've got aluminium and a 2. There's 2 aluminiums. Aluminium is 27, so it's 27 plus 27. Sulfur's inside the bracket, there's a number 3 outside. That means I've got 3 sulfurs, okay? So I can write 32 3 times, but I'm just going to do 32 times 3. Now the last bit is probably the hardest. There's 4 oxygens inside the bracket, there's 3 outside. Brackets mean multiply just like they do in math. So I've got 12 oxygens in total. 4 3s are 12. Oxygen has a mass of 16. There are 12 oxygens, so you've got 16 times 12. And when I do all this out, I get, sorry, bear with me, 32 times 3 plus 54. I get 342. All right, the next set of questions are percentage by mass of an element, all right? So the percentage by mass of oxygen in CO2. Again, I'm going to be using formula mass here. So oxygen has a mass of 16. There are 2 oxygens in carbon dioxide. So I'm going to do 16 plus 16 for the 2 oxygens in carbon dioxide. On the bottom line, I'm going to do the formula mass of the whole thing. So I've got a carbon and I've got 2 oxygens. So bottom line, formula mass of the whole thing. Top line, just the element they ask you about. In our case, it's oxygen. Then you times that by 100. So on the top line, I've got 32. On the bottom line, I've got 44. I times that by 100, and I'm going to write my answer to 1 decimal place, 72.7%. So that tells me that 72% of carbon dioxide is made up by oxygen if I use mass. Right, have a go at doing questions 2 and 3. Press pause. Do have a go by yourself, please. Okay, first one, I have got 1 magnesium in magnesium carbonate. So I've got 24 on top, which is the mass of magnesium. On the bottom, I'm working out all of magnesium carbonate. So I've got a 24 for the magnesium, a 12 for the carbon, and then 3 16s because there's 3 oxygens. When I work all that out, I get 28.6%. The next one, I'm looking at oxygen in H2SO4. Now there are 4 oxygens, so I've got 4 times 16 at the top, At the bottom, I work out H2SO4. I'd already done that in question 1. I know it's 98. When I times it by 100, I get 65.3. Next question is empirical and molecular formula. So 2 types of formula. Molecular formula tells you exactly how many atoms you've got in a molecule. So if I had glucose, there's 6 carbons, 12 hydrogens and 6 oxygens. That's the molecular formula. If I want empirical formula, I need to simplify this ratio. The biggest number that divides evenly into 6, 12 and 6 is 6. And if I divide all of those numbers by 6, 6 divided by 6 is 1, 12 divided by 6 is 2, 6 divided by 6 is 1. So I can simplify this formula by dividing across by the biggest number that divides in evenly. So molecular is the actual number of atoms, empirical is the simplest whole number ratio. I want you to have a go at questions, all right? Now I've drawn you 2 molecules, so to get the molecular formula, you literally just need to count, and once you've got a molecular formula, try and simplify by dividing across. I've done the molecular formulas, okay? All I had to do was count. There were 4 carbons, so I wrote C4, 10 hydrogens, I wrote H10. Over here I had 4 carbons, so I wrote C4, 8 hydrogens, H8, and 2 oxygens, O2. So that's the molecular formula when you just count the atoms up. Empirical, I need to simplify. So the biggest number that goes evenly into 4 and 10 is 2. If I do 4 divided by 2, I get 2. 10 divided by 2, I get 5. So that's molecular, this is empirical. The next one, I've got 4, 8 and 2. Again, the biggest number that divides evenly is 2. 4 divided by 2 is 2. 8 divided by 2 is 4. 2 divided by 2 is 1. So actual number is molecular, simplified ratio, that is empirical. The next is more empirical formula, but this time you've got a little calculation to do. They love asking this. They always ask this, okay? So calculate the empirical formula and they give you the mass of different elements. So I'm going to do this using a table, okay? Now they say I'm reacting sodium with oxygen. So in my table I'm going to put Na and I'm going to put O. Now the first line of my table is going to be whatever they've given me in grams. So the grams of sodium is 0.92. The grams of oxygen is 0.32. So that's the first line. The next line in my table is the number that they give me in brackets. So there won't be any units, they'll always be in brackets. Alright, so second line, sodium has the number 23, oxygen has the number 16. The third line of my table, I divide. So I do 0.92 divided by 23, and I get an answer of 0.04. Then I do 0.32 divided by 16, and I get 0.02. Final step is I need to simplify this ratio. I need to get rid of all the decimal places and get whole numbers. To do that, I look at the 2 numbers and ask myself which is smaller. 0.02 is smaller than 0.04. That means I divide both numbers by 0.02. Okay, so whichever one is smaller, you divide everything by the small number. When I divide it by itself, I get 1. When I divide 4 by the 2, I get 2. So I've got the same ratio, I've just gotten rid of all the decimals. I've now got a 1 and a 2. And the final step is to write the formula. I write down my Na. On the Na side, there's a 2. I write it down small. Then I write down my O. On the O side is a 1. I write that down small. That's empirical formula. So G's on the top, the number in brackets second line, top divided by the second line to get the third line, and then whichever number is smaller, you divide across by the small number. You have to write the formula at the end to get the final mark. I want you to have a go at questions 5 and 6, where you're asked to calculate empirical formula. Okay, so I've got silicon and chlorine. First line is grams, so 1.4 is the grams of silicon, 7.1 is chlorine. Second line is the number in brackets, 28 for silicon, 35.5 for chlorine. Then I do top line divided by bottom line, and I get 0.05 and 0.2. This one's slightly harder, okay, but you need to see which one of these numbers is smaller. Because it's 0.05, this number is smaller than the 0.2. That extra 0 there makes it smaller. So I divide both numbers by 0.05, by the smaller number, and I get 1 and 4. I then write the formula. On the silicon side, Si, I've got 1 of them. On the chlorine side, Cl, I've got 4 of them, SiCl4. The next one works out very similar. This time I've got tin, which is Sn. Sorry, I didn't give you the symbol for that, but tin is Sn, and I've got Cl, which is chlorine. Grams of tin, 1.19. Grams of chlorine, 1.42. Divide by the number in the brackets. This is what I get. Of these two numbers, which is smaller, 0.01 is smaller, so I divide both numbers by 0.01, I get 1 and 4, so I have a formula similar to above, I get SnCl4. Right. Other one that they ask every single time is concentration. You take 50 grams of NaCl, you dissolve it in 200 centimeters cubed of water. Give your answer in grams per decimeters cubed. They always give you this unit, and the unit tells you what to do. Whatever you've got in G, that goes on the top line. All right, so G comes first in the unit, G goes first into your calculator, 50 grams. You then divide that by whatever you've got in dm cubed. Now, if you look, we don't have anything in dm cubed. We've got cm cubed, so you're going to have to do a unit conversion. So to go from cm cubed to dm cubed, you are going to divide by 1000, and it will always be the same conversion. So I do 200 divided by 1000, and I get 0.2 dm cubed. Now I've got something in grams divided by something in dm cubed. I just do that on my calculator, 50 divided by 0.2, and I get 250 grams per dm cubed. I want you to have a go at questions 7 and 8. Have a go at doing that one for yourself. Alright, we've got these two answers here. Alright, I've got 40 G's, that goes on the top line. 200 centimeters cubed, again I need to divide by 1000 to put that into decimeters cubed, and then it becomes 40 divided by 0.2. This is your answer. The next one, I've got 65 grams on the top line. Grams is always on top. Put this into decimeters cubed by dividing by 1000, and I get 130 grams per decimeters cubed. Right, very last one. It's called Law of Conservation of Mass. And all it says is that the total mass on the left-hand side of the arrow has to match the total mass on the right-hand side. If you've got 50 grams on the left, that means in total you must have 50 grams on the right. If they're telling you that 20 grams is calcium oxide, how much will be the CO2? They have to add up to 50, therefore this must be 30. Okay, so effectively if you do 50 minus 20, you get this mass over here, which is 30. So you just need to know that they have to be the same on both sides. Right, final question. Just do this for me, please. Alright, so I've got 100 grams on the left. That means I must have 100 grams on the right. At the moment, I've only got 60. Alright, I need to have 100. 100 minus 60 is 40. That means the CO2 must be 40. We'll do some exam question practice on this in the lesson, but they are all of the calculation type questions that they ask.